Hello everybody. So today I'm going to do some practice with a function in terms of x and t, and I'm going to say that t is equals 0. So our psi at t equals 0 is equals to a, then psi, um, sorry, little psi 2 in terms of x plus 3 psi 3. This one is a in terms of x, and this is our function. So first of all, we have to normalize it. So we have to find what this a value is equal to. In order to do this, we have to integrate this from the lower boundary to the upper boundary, and we know that this value, this function, works when x is in between 0 and a. So I'm just going to go from 0 to a of this squared. So I'm just going to rewrite it like this, dx. Now, the time value doesn't matter, so this is equal to simply our little psi squared dx, which is equals to what? Well, derivative from 0 to a of our a squared, and then I'm gonna have the actually I'm gonna write it I'm gonna write it the long way. So I'm gonna have the first psi times the second psi, and the first one is gonna be a composite conjugate dx. Now, what is the composite conjugate of our function? Well, it's gonna be the same function as before. It's gonna be our same function as before. So I'm gonna rewrite. I'm gonna say from 0 to a, and then I'm gonna have the a squared in front. So the first one will get to be, I'm gonna write it actually in the correct way. So I'm gonna have the psi 2 in terms of x, and then 3 psi 3 in terms of x, and this, remember, it's one column, two rows, times our initial function, which is equals to this. Okay, dx, of course. So now let's multiply these two. I get that I'm going to take out the a squared in front, because it's constant, doesn't matter, from 0 to a, of, I get our psi 2 in terms of x times psi 2 in terms of x, plus we get 3 times 3, so 9, psi 3 in terms of x times psi 3 in terms of x dx. And I know that this part over here is going to be equals to 1, and as well as this part over here is going to be equals to 1. So here I have that a squared and the integral from 0 to a of what it's going to be is going to be 1 plus 9 dx. Yes, sorry, okay, has to be equals to 1, of course. So what do I have to do? Well, I simply have to substitute it. I get a squared, so actually a absolute value is equals to 1 over, let me write a little bit closer, 1 over square root of 10. And that's what I get out of it. Sorry, that's my normalization constant for my value. So I can rewrite my capital psi in terms of x and t. So my a is going to be equals to 1 over square root of 10, and then it's going to be the same thing up here. I'm just substituting the a, and then the t value is going to be equals to e to the power of negative I e t over h bar.